Hello. A couple weeks ago, I made a project that allows me to open a door remotely by only sending a WhatsApp message. I made this project because every time I had to open the door for someone that is outside, I had to go to the kitchen and click the intercom. I thought this was kind of boring because I had to stop doing whatever I was doing and go to the kitchen and open the door. So I made a more practical way to open the door from anywhere. This is the flowchart that we are going to use for this project. As you can see, once we send a message, this is going to go through the WhatsApp API. So we are going to use Twilio.com, which is a provider of this API. Once this message is received by one number of Twilio, it is going to trigger an API call to our API gateway on Amazon Web Services, and then a Lambda function is going to evaluate if that message matches the password that we set. If it does, it is going to make a GET request to our local server, which is in charge of opening the door. By the number of steps, you may think that this is going to take a lot of time from the time that we send the message until it opens the door, but trust me that it takes less than 1 second. So let's start.
Okay, so this is the hardware schematics for this project. The ESP is going to turn on the relay for 1 second because it's going to simulate like someone is pressing the intercom button to open the door for 1 second. And something very important here is that you first have to measure the voltage of your intercom button. In my case, it was 12 volts AC, but yours can be 12 volts DC, 5 volts DC, or whatever the other value. And with that value, you can choose a proper relay to make this project work. So the first thing we are going to do is to create the web server on the ESP. So let's open the Arduino IDE. Here we will copy and paste the code of the repository, which is here. So we copy the code of this file. We just copy everything and we paste everything here. And there are only a couple of things here that you are going to replace, which is the SSID and the password. The SSID is the name of your Wi-Fi network, and the password is the password of your Wi-Fi network. We will save. The components and the ESP are already connected to the computer, so I will just click on upload. And while this is uploading, I will give you a brief description of the code. This is the relay P, which is number 4, which is the 2 on the ESP. This is the port of the web server that we are going to use. I will give you more details about that later. This is the duration of the pause, which I said at the start was going to be 1 second. And here is the setup where everything is started. And here we start the client, the web server. And here the request is created. I will tell you a bit more later. And this is the UI for this example. This will help us understand a bit more on how this works. So it has already been uploaded. So we click on serial monitor, and this part is very important. Here says that the IP address that the Wi-Fi gave you is this, so we need to copy and paste this URL on the browser. So this is the web server. It's very simple. It only has a button that switch the relay on for 1 second. This is very helpful to verify that the code and the connections are working properly. So if I click this, you will hear the relay turning on for 1 second. So I better also show you what it's going on here. This is the ESP and this is the relay. So here in the computer I'm going to click on this button so you can see and hear that everything is working properly. Yes. Well, there's the first step complete. The second step is that we need this URL to work, but not only locally, which is working right now, but it should work from everywhere in the world. So in order to do that, we need to modify a couple of things in our router. So we go to this URL, which is your local host for your router. We enter the credentials. If you don't have the credentials, you can ask your ISP. Your router admin layout can be a bit different, but the options are almost the same. So we go to internet here, and here we need to make sure that one blocking or something similar is turned off, like this. Then we go to port mapping. I click here, I write a service name which I call your door server. The LAN IP is the local IP. Remember that this was printed on the output monitor of the Arduino IDE, which is this. It's the same. The protocol we choose both. Here in port we write 200, which is the port that we wrote in the code, which is also here and here. So we save. Yes, it's done. So once we have created this port forwarding, we click on apply. Okay, so once you have done this, we need to check our public IP. In order to do that, we can just Google that with what's my IP, and this is our public IP. This will allow us to enter this server from anywhere around the world. Remember that this URL it's only working locally, but we need this to work from anywhere around the world. So to test that, we copy this IP and we also add the port, and we can test it here. I recommend you to go to this URL but on your phone, using your phone data, not your Wi-Fi data. That will give us a 100% confirmation that our public server is working. So the next step is to go to Amazon Web Services. Okay, we will use Amazon Web Services here because it's free for 1 year, so you can create an account and use the service that I'm going to show you right now. So once we create the account, we type for the Lambda service and we create a function. This function is going to read messages from WhatsApp and verify that, for example, the message sent through WhatsApp is correct, and so we need to open the door. So we type a name, we call it door server function, and runtime we choose Python 3.10 and we click on create function. Okay, once it's created, we are going to copy and paste the code of this repository, but this code. We copy this and we replace everything here. We then click on deploy. Okay, after deploying, we go to configuration, we go to environment variables, and we click on edit. And here we write the sensitive information like our web server URL, in this case web server, and the value is this. Remember that this is your public IP and this is the port. We add another environment variable which is going to be the password, and you can set any password here. So the message sent to WhatsApp should be equal to this password so we can open the door. This is one of many security measures that you can implement for this project. We click on save and we go back to code. I will give you a brief explanation on this. Okay, this web server, we are getting this from the environment variables we just typed a couple of seconds ago. This URL to turn on the relay is the URL that we are going to make that GET request so we can turn on the relay. This is the password that we are getting from the environment variables, and here this line is getting the message from WhatsApp. For example, if I send a message saying hello through WhatsApp, this message is going to be equals to hello. So we need this so we can compare this message to the password, and if the message matches the password, then we can make this request to turn on the relay. It's a way to secure our door, because if we send whatever other message through WhatsApp, it is just going to ignore it. So you can share this password with the people that you want, so they can also open the door with this code. So the next thing is we need to create an API with the API gateway service of Amazon Web Services. In the search bar, we search API gateway, and then we click here on create API. We choose REST API and we click on build. So we give a name for this, which is your server API. We click on create API, and here we create a resource. We click on actions, create resource. We call this open. We click on create resource. Then we click on the resource we just created. We click on actions, we create a method. We choose any. We click here in this check button, and here we choose Lambda function. We check this Lambda proxy integration, and here we search for the function we created in the last step. We call this door server function, and we click on save. Yes, we click on OK, and finally we click on actions and select deploy API. We select new stage, test, we click deploy. Okay, so I will just recap the workflow that I explained at the start. Once we send the message through WhatsApp, that message is going to trigger this API, which is connected to this function we created here on Lambda. That message is going to be read, and it's going to be compared to the password. And if that message is equal to that password, we open the door, which means we activate the relay. Okay, so the final step is to create an account on Twilio. We get a few dollars on trial, and that's more than enough for this example. So once we have created our account, we see this console. We go to the left and we expand the messaging menu. We click on try it out and send a WhatsApp message. Okay, so here we need to send this message, join Shoeboat. Yours can be different, to this number. Why? Because when you send this message to this number, the trial service is going to know that your number is allowed to interact with this bot, with this Twilio bot, and only people that join this sandbox with this message can interact with this bot. So we just copy this, we open WhatsApp. So this is the number. I have saved this number in my contacts. I call it Dur. So I type join Shoebot, and this message is a confirmation that we have set up this correctly. So the next part is to go to, so you see here that this has changed because it has already detected that we send this message, but we are not going to use any of this for this example. We just go to sandbox settings, and here in the when a message comes in field, we copy this URL of our API, we paste it here, and we add /open. Remember that open is the resource that we created, because if we leave only like this, it will not work, we will just get an error. So, and method, we choose post and we click on save. So here I will do a recap very quickly. Okay, so once a message comes in, this API URL is triggered, and when this is triggered, remember that we chose to execute this function. So if everything is working, if I send here the password that I set, you will hear the click sound of the relay. Okay, remember that the password we set is here in configuration and environment variables, and is the password key. In this case, it's abracadabra for me. So here I just type this, and yes, did you hear the sound? I will move the camera so you can see it better. I will just. So once I click, you will see and hear the relay turning on. So 1, 2, and 3. So it's working. The only thing we have left is that we need to connect this relay to the intercom button, which I'm going to show you right now. Okay, so I'm gonna try this with my real intercom. As you can see here, I'm showing you the chat with the password. So I'm gonna test. Okay, and finally I will show you how it's working in real life. As you can see, this is the message. So I will just send the message.